The North Pole aurora lights, also known as the Northern Lights or Aurora Borealis, represent one of the most awe-inspiring natural phenomena on Earth, captivating observers with their ethereal beauty and the scientific wonders behind their creation. The Northern Lights are a result of charged particles from the Sun, primarily electrons and protons, colliding with gases in Earth's atmosphere, such as oxygen and nitrogen. This interaction occurs in the ionosphere, a region of the upper atmosphere located about 60 to 600 miles above the Earth's surface, where the energy from the Sun's particles excites these atmospheric gases, causing them to emit light. The resulting display creates a stunning array of colors, predominantly greens and pinks, but sometimes extending to reds, yellows, blues, and even purples. The specific colors of the auroras depend on the type of gas involved and the altitude at which the interactions occur, with oxygen typically producing green and red hues, and nitrogen leading to blue and purple shades. The phenomenon is most commonly visible in regions near the magnetic poles, where the Earth's magnetic field is strongest, guiding the solar particles toward these areas. The North Pole, with its close proximity to the magnetic north, is one of the prime locations for viewing the aurora borealis, attracting tourists, photographers, and scientists alike from all over the world. The auroras are most visible during the winter months when the nights are longest and the skies are darkest, providing optimal conditions for the lights to shine brightly against the backdrop of the Arctic night. These displays can last for several hours, shifting and shimmering across the sky in patterns that range from subtle arcs to dynamic, rippling curtains of light. The Northern Lights have been a source of fascination and inspiration for centuries, with various cultures attributing mystical and spiritual meanings to the lights. In some indigenous cultures of the Arctic, the auroras were believed to be the spirits of ancestors or animals, while in others, they were thought to be the flames of celestial warriors or the reflections of fires in the heavens. Scientifically, the study of auroras has provided valuable insights into the workings of the Earth's magnetosphere and the effects of solar activity on our planet. The phenomenon is closely linked to the solar wind, a stream of charged particles released from the Sun's corona, which carries with it the magnetic field of the Sun. When these particles reach Earth, they interact with the planet's magnetic field, causing disturbances that result in the beautiful auroral displays. The intensity and frequency of auroras are influenced by the solar cycle, an approximately 11-year cycle during which the Sun's activity increases and decreases. During periods of high solar activity, known as solar maximum, the Northern Lights can become more intense and are often visible at lower latitudes, extending their reach beyond the polar regions. Conversely, during solar minimum, the auroras are less frequent and primarily confined to higher latitudes. The North Pole's unique position on the Earth provides an unparalleled opportunity to witness these spectacular displays in their full glory. The region's remote and pristine environment, far from the light pollution of populated areas, ensures that the auroras are seen in their purest form, with the dark, star-filled skies providing the perfect canvas for the lights to dance upon. For scientists, the auroras offer a natural laboratory for studying space weather, the interaction of solar radiation with Earth's magnetic field, and the impacts of these processes on satellite communications, power grids, and even climate patterns. The auroras are also a reminder of the dynamic relationship between the Earth and the Sun, a relationship that has profound implications for life on our planet. The study of auroras has led to the development of instruments and techniques for monitoring solar activity and predicting geomagnetic storms, which can have significant effects on technology and infrastructure. For travelers and adventurers, the opportunity to witness the Northern Lights is often described as a once-in-a-lifetime experience, a chance to see one of nature's most beautiful and ephemeral displays. Many who have witnessed the auroras describe them as a deeply moving experience, a reminder of the beauty and majesty of the natural world. In the North Pole region, the lights can be seen from various locations, including the Svalbard archipelago, northern Norway, and parts of Canada and Alaska, with some of the best views found in remote areas far from human habitation. The auroras are not only a visual spectacle but also a source of cultural and historical significance, with the lights playing a role in the mythology and folklore of Arctic peoples. The Inuit, Sami, and other indigenous groups have rich traditions and stories associated with the Northern Lights, often viewing them as a bridge between the human and spiritual worlds. The scientific study of auroras began in earnest in the 18th and 19th centuries, with explorers and scientists seeking to understand the mechanisms behind the lights. The first scientific explanation of the auroras was proposed by the Norwegian scientist Christian Birkeland in the early 20th century, who suggested that the lights were caused by electrons from the sun being guided by Earth's magnetic field into the polar regions, where they interacted with the atmosphere to produce the glowing displays. Birkeland's work laid the foundation for modern auroral science and our understanding of the complex processes that produce the northern lights. Today, researchers continue to study auroras using a variety of tools, including ground-based observatories, satellites, and even rockets, to probe the upper atmosphere and gather data on the interactions between solar particles and Earth's magnetic field. These studies have revealed the intricate dynamics of the magnetosphere, including the role of magnetic reconnection, a process in which magnetic field lines in the Earth's magnetosphere are stretched and then snap back together, releasing energy and creating the auroral displays. The auroras are also linked to the broader field of space weather, which encompasses all of the interactions between the Sun and the Earth's environment. Space weather can have a wide range of effects, from beautiful auroral displays to potentially damaging geomagnetic storms that can disrupt communications, navigation systems, and power grids. Understanding and predicting space weather is a key area of research, with important implications for both scientific knowledge and practical applications. The northern lights are not confined to the North Pole. A similar phenomenon, known as the southern lights or aurora australis, occurs in the southern hemisphere, primarily around Antarctica. However, the northern lights are more widely known and more frequently observed due to the larger population centers in the northern hemisphere. The study of auroras is a truly global endeavor, with scientists from around the world collaborating to share data, develop models, and advance our understanding of these fascinating phenomena. The northern lights continue to captivate and inspire people around the world, serving as a powerful reminder of the beauty and mystery of the natural world and the complex forces that shape our planet. Whether viewed as a scientific curiosity, a spiritual experience, or simply a breathtaking display of nature's artistry, the northern lights hold a special place in the human imagination, drawing us to the remote and rugged regions of the north in search of their elusive and ephemeral beauty. The auroras are a testament to the power of nature and the interconnectedness of the Earth and the Sun, a relationship that has shaped our planet for billions of years and will continue to do so for billions more. The northern lights are a symbol of the wonder and majesty of the universe, a reminder that we are part of a vast and dynamic cosmos, and that even in the darkest and coldest places on Earth, there is beauty and light to be found. For those who have the opportunity to witness the auroras, the experience is often described as unforgettable, a moment of connection with the natural world that leaves a lasting impression and a deep appreciation for the mysteries and wonders of our planet. The northern lights are a natural wonder that transcends borders and cultures, uniting people in their shared fascination with the beauty and power of the natural world. Whether seen from the frozen tundra of the Arctic, the rugged mountains of Norway, or the remote wilderness of Alaska, the northern lights are a reminder of the incredible forces at work in the universe and the fragile beauty of our planet. As we continue to explore and understand the science behind the auroras, we are also reminded of the importance of preserving and protecting the natural environments that allow us to witness these incredible displays. The northern lights are a gift from the universe, a source of wonder and inspiration that connects us to the cosmos and to each other, reminding us of the beauty and mystery of the world we live in.